You've already graphed sine function with dilations. Now we're going to graph cosine with dilations. Let's review parent function for cosine. The coefficient is 1, which makes the amplitude 1. And that has our graph go up 1 from the horizontal and down 1 from the horizontal, so that the range is -1 to 1. On the x-axis, parent function goes from 0 pi to 2 pi. That is the domain of one phase. 2 pi minus 0 pi is 2 pi. The length of one phase is 2 pi. Those are the endpoints. We call those critical points. We're also going to find some midpoints. Halfway between 0 pi and 2 pi is pi. Halfway between the first two is pi over 2. And down here is 3 pi over 2. We are going to use 5 critical points, we call these critical points, to graph our function. And then cosine starts at, this is where it's different. Everything I've done so far is just like we did with sine, but now we're graphing cosine. Cosine starts at the maximum, and then to 0, and then to the minimum, and then to 0, and then to the maximum. And we draw a curve. Don't make it look like a V. It is curved at the top and at the bottom. So in general, with the transformations we're going to look at today, there might be a reflection. A negative A causes a reflection over x-axis, horizontal axis. It won't always be the x-axis. If I take the absolute value of the coefficient, whether it's positive or negative, that's our amplitude. And it indicates a vertical dilation. Does the graph get taller or does it get shorter? That's a vertical dilation. And finally, if my argument has a coefficient, that coefficient creates a horizontal dilation. Which affects the frequency. We use that coefficient to find the period of the new graph. The period would be 2 pi, or 360 if you're working with degrees, divided by that coefficient that's on the argument. Let's do a couple of examples. Here we have cosine of 4 cosine of 3/4 x. I was just noticing this is numbered 3, which is silly, and that distracted me. No big deal. We will look at the coefficient. The coefficient is 4, which makes the amplitude 4. 4 above the horizontal, 4 below the horizontal. The range of this graph will be -4 to 4, including those values, so I used brackets. On the x-axis, I will take the argument with x, I use radians. I'll set it equal to 0 pi and 2 pi. Multiply by 4. Divide by 3. We still start at 0 pi. Multiply by 4. And we stop at 8 pi over 3. Ooh, exciting. That makes our domain 0 pi to 8 pi over 3. To find the period, we can either subtract those values, 8 pi over 3 minus 0 pi, or we can take 2 pi divided by the coefficient. And when I multiply by the reciprocal, I will get 8 pi over 3. Two different ways. Eventually, you might need to use one of those methods over the other. That's why I keep repeating both. And we label the end on our graph. The math is a little trickier for this one. I'll do the math off to the side. Half of 8 pi over 3 is 8 pi over 6, which can be reduced. 4 pi over 3. Then when I have to find half of 4 pi over 3, I get 4 pi over 6, which can be reduced to 2 pi over 3. And the tough one. I'm finding an average between these two. So I'm going to add those up. 4 pi over 3 plus 8 pi over 3 is 12 pi over 3. Divide by 2, which means take half. That gives us 12 pi over 6, or 2 pi. So you're always finding an average. If the numbers are a little difficult, you just add them up and divide by 2. So now let me get that out of the way for our graph. We have our 5 critical points labeled. We're going to draw our cosine. We have to pay attention that we're graphing cosine and not sine. Cosine starts at a maximum, then to the horizontal, then to a minimum, horizontal, maximum. There's our cosine graph. We're going to try one more together. This one has a reflection. So instead of starting at a maximum, it'll start at a minimum, and then follow the same pattern. Amplitude is absolute value of the coefficient. And my graph is going to be a little shorter. You can scale it however you want, but it means the graph is half the distance from the horizontal axis as parent function. And our range will go from -1/2 to 1/2. On the x-axis, we will set the argument equal to 0 pi and 2 pi. Multiply by 5. Divide by 3 pi. The pi cancels out, and 0 divided by 3 is 0. Not 0 pi, but 0. Multiply by 5. Divide by by 3 pi. Again, the pi cancels out. My one phase of this cosine graph ends at 10/3. Oh, we've got some good fractions we're working with today. 10/3 minus 0 is 10/3. That's the easiest way to find period this time. Halfway, if I do half of 10/3 is 10/6, or I could reduce, it becomes 5/3. Halfway, half of 5/3 is 5/6. And for the last ones, we want to add up and get 15/3. 5/3 plus 10/3 is 15/3. Don't forget to multiply that by 2. And we have lots of simplifying we could do. 15 divided by 3 is 5, and 5 times 1/2 is 5/2. We always want to simplify. Now we are ready to put in our cosine graph. Don't forget that it's reflected. That's so easy to forget right at the end. It is reflected. That's why I give myself a big old note in red. That means I start at a minimum, then go to the horizontal, then a maximum, horizontal, down to a minimum. And make sure it's curvy, not pointy. There's your cosine graph with dilations. Next, we're going to be starting translations. Those are a little tougher, so make sure you can really do the dilations well.